Hey, welcome to the series of everything you need to know about Python in simplest possible way. In our previous video, we have seen arithmetic operators, relational operators, and also seen logical operators. In this video, we will see bitwise operators and how this bitwise operator works. So, bitwise operators used to operate on numerical values by converting those numerical values to the binary level and perform some of the bitwise operators. Like we have different bitwise operators like bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, and also we have some of the shift operator like left shift, right shift. So to understand this, we will firstly try to understand how this conversion of numerical values to binary digits and how these binary digits can be converted into integer values. So going ahead, I am considering this binary method. So why this binary method is used? Because to convert any integer value to binary value, we will be using this binary. So binary method. So I am passing, let's say, 7 here. When I pass 7, I am able to get this binary representation. So here, if you carefully observe, I am getting 0b, which is used to represent that this is a binary representation. For what? For these values. So this is what the values we are having here. 7 is represented in binary as something like this. So I will take some other example, let's say 43. So 43 can be represented something like this binary representation. So here we will be considered only 3, but here we have considered 6. Depending upon the bit values, let's say how many ones that can be fit in these values, based on that only we are considering that many digits. So because of that reason, here we are considering 3 and here we are considering 6. So this is how we can convert numerical and specifically integer value to binary level. So let us try to understand how we can convert this binary to integer. Let's say I am taking this binary value, I am copying this, and to convert this binary to integer, I am using this integer method and I am pasting this binary representation, whatever the 43 it is. So if I execute this, I will get an error saying invalid literal for int with base 10, whatever the thing that we have passed here. So why I'm getting this error is because I am having this b. So and also one more thing that we need to have idea is that here we are converting only binary digits to integer value. So because of that reason I am mentioning 2 here. So telling Python that I wanted to convert these binary zeros and ones to integer. So if I execute this, I can able to see 43 here as output. So that is how we can actually get the output. We can actually convert this integer value to binary value by using bin, and we can actually convert this binary value to integer value by using this integer by mentioning these two here. So let us go ahead and understand what are the different operators that we are having, what are the different bitwise operators we are having in Python. So initially we will be having this AND operator. So this is represented as logical bitwise AND. So Python internally convert these numerical values to binary level and perform these operations. So I'm considering this, let's say I'm considering 43 and logical AND with let's say 58. So what I will be getting is 42. So let us try to understand by converting each of these value to binary level. So how this and bitwise AND works. So to do that, I am passing 43 here and also I am passing 58 here. So let us try to understand by comparing these two values. So I am copying here this 43 and also I am copying this 58. I am pasting here. So let us, for the time being, let us remove this 0b because this 0b represented only to this is a binary. So because of that reason, we are removing these b's. So if we carefully observe here, so this is the what we have got for 43 and this is what we have got for 58, right? So now we will try to understand how this works. So logical AND works in a such a way that whenever it encounters um, at least two positive values, to be specifically two ones, then only it will return as ones. If and encounters any one zero, it will represented as zero itself. So here, if to understand, so for that reason, here we were having first digit as 1. So that reason we will be getting 1. Here we are having 0 and 1. So it encountered a single 0. Because of that reason, the answer will be 0 itself. So here we are having both ones. So logical and can be represented both ones as 1. So here we are having 0. We have encountered 1 0 and 2 zeros. The answer is 0. Here we have two ones, the answer is 1. Here we are having 1 0. So because of that reason, we will be getting 0. So if I go ahead and copy this value, and let me take this value and convert this to integer. So I'm pasting this value here and I am mentioning it as 2. I am converting this binary. So the same result you can see in both here by directly converting this by bitwise and operator. By understanding this and by converting this each value to binary level and operator, we can actually get the same result here. I hope you have understood how exactly this binary and operator works. So to summarize, binary and takes two values like zeros and ones. If it encounters any single zero value, it will consider it as zero. If it encounters only two ones, then only it will consider it as one. So I hope you have understood what exactly that means. So let's go ahead and understand this logical OR operator. So this is how logical OR, bitwise OR represented with this symbol. So let us see maybe the same example what we have seen here. Let's say I will taking this 43 or bitwise OR 58. So when I execute this, I am getting the result as 59. So let us understand how this bitwise OR works. So for that I am converting this 43. We have the result previously, but still I am converting this 58. So I am copying these two values to understand how this bitwise OR works. So let me copy this. Let me paste here. So this is the values that we have got. So we will remove this B0B also. So now, how exactly this bitwise OR works is that whenever it encounters at least one value, which is also referred as at least one true value, it will consider as true. If it encounters both or false or also referred as zeros, then it will be consider them as zero. So here, if we consider here, we are getting two ones, which could be, so the resultant bitwise OR will be 1 because we have encountered 1. So here, if you consider, we have encountered both are one is 0 and the other one is 1. So we have encountered 1 1. So because of that reason, the answer will be 1. Here we are getting two ones, so the answer could be 1. So here, if you carefully observe here we are getting both are zeros. So we will be represent bitwise or take it as 0 because we haven't got any single one. So because of that reason, we will be resulting that as 0. Here we have got 1 1. So the answer will be 1. Here we have got 1 0. The answer will be again 1. So this is how we will be getting for this both 43 and 58. Let us go and check that is true or not. So I am copying this value and I am pasting this value. I am representing 2. So I am getting 59. So you could compare these values, whatever the value directly written by the Python, which is by saying 43 bitwise and bitwise OR with 58. And also we have seen the manual procedure by converting each of these bits. So we could see the same result here 59 and also 59 here. So I hope you have understood what a logical bitwise OR is. So let's go ahead and see one more operator, that is bitwise XOR. Bitwise XOR is little different from all from what we have discussed with and OR. So let us take the same example 43 or XOR with 58. So if I execute this, what I will be getting? I am getting 17. How we are getting 17? Let us understand that. So I am copying the same result here. So instead of not doing the same thing again and again, so I am copying those values of 43 and 58. So let us understand how this bitwise XOR works. So XOR works in a such a way that whenever we are getting two different values, at that time we will be mentioning that with 1. Whenever we are getting two same values, at that time we will be mentioning that as 0. Here, to understand, let us consider this. Here we are getting same values. So as we are getting same values, we will be representing with 0. Here we are getting 0 and 1. Two are different values, right? So at the time we will be representing with 1. Here we are getting same values, we will be representing with 0. Here we are also getting same values, we will be representing with 0 again. Here also we have, as we got same, so here also we will be getting same, so I will be mentioning with 0. Here also, here we will be getting different values like 1 and 0, so I am mentioning it with 1. So that is how this XOR works. So let's go ahead and convert this into integer. So I am considering this by copying this, and I am passing this to integer by mentioning that this is a binary representation. I am getting the result as 17. You can see the same result what we have got with XOR of direct XOR operator by Python, and manually we have converted these 43 and 58 to binary, and we have got the same result. So I hope you have understood how this XOR works. To summarize, XOR, when we have two different values like 0 and 1, 1 or 0, at the time the resultant will be 1. When we have same values like 0 0, 1 1, at the time we will be resulting, the XOR will be resulting as it 0. So that's how it works. So let's go ahead and see one more thing, which is of bitwise not. Bitwise not representing with this symbol. So this is the symbol that we use to represent bitwise not. So bitwise not is used to convert one to another. Each bits will be converted from, if the value is 0, that will be converted as 1. If the bit value is 1, that value is converted into 0. Let us go ahead and see with example. Let's say I am having this 43. To this 43 I wanted to do bitwise not operator. So I am mentioning this symbol, and if I execute this, I am getting as minus 44. How does that happen? So let us understand by some manual approach. Let's say I am passing this 43 here. You can see the result something like this. So I am getting 101011. If I pass this negation symbol and with 43, I am getting minus 0b 10101100. If you carefully observe, so to make this simple, I am copying these two values. This is what we have seen directly. This is what the 43 initially having. By applying the value of negation, I am getting this value. So initially I have got minus also. So I will put a space here so that I will get this thing clear. So here, how does this bitwise negation not operator works in a way that whenever, let us make it as integer, let us consider as integer. So whenever we have passed this integer 43, if you carefully observe, we have initially got minus. So if you pass positive value, the resultant would be negative value. That is a one thing. And the another thing we will understand through this, we have got, this is 43 that we are having, and this is minus 44. This is 43 that what we have passed by negation. This is minus 44 that what result is came. So sorry. So whenever we have this whenever we pass this positive value, it will try to find the first 0 and convert that 0 to 1. Here, if you carefully observe, here we are getting first 0 as here, and this 0 is not here. Here we have first 0 here. It will try to go until it finds the first 0 value. So whenever it finds the first zero value, at that time it will convert that 0 to 1 and stop the process, and that will be resulted. So here, till then it will try to interchange the values. Here, if you carefully observe, here we are getting 1. So this 1 initially converted to 0, and we are getting 0. This 1 converted to 0, and here this is where the point we have got 0, and this 0 is converted to 1 and it stops the process. So this is where the process is stopped. From this point onwards, it doesn't consider it doesn't change anything except by mentioning 0, by mentioning minus at the end. So by this you can able to understand that this negation works whenever you are passing positive value. It will find the binary 0, and until then it will try to convert those ones to zeros. Whenever it finds the binary 0, it will convert that binary 0 to 1 and stop the process and returns the value. So this is what the value that we have got by this. So this is about the positive value by converting, by applying negation. Let us consider by taking a negative value. How does that negative value will be converted? Let's say I am taking negative value maybe of minus 53. So I am getting this direct negative value. Let me apply this negation here. I am applying negation here. So the result what I am getting, let me compare this result so that you could understand it more clearly. So here, if you carefully observe here, this is what the initial value that I am taking, which is of minus 53, and here is what the resulted value, which is of we. Okay, fine. We have applied directly, so we will apply this negation of minus 53, and the value that we have got is 52. So let us understand how we have got 52. So here, whenever we are passing this negative value, it will try to find first one occurrence. Whenever it finds one, it will convert that one to 0 and stop the process. Here, if you can carefully consider here in the first instance itself, we are getting 1. So it was converted this 1 into 0 and it stops the process. If you carefully observe, from this point onwards, this doesn't change anything. Everything as it is. So except by mentioning positive at the end, here we are passing negative and here we are getting positive. So that is how this negation works with the passing negative values. It will try to find the first one occurrence, and whenever it finds the first one occurrence, it will convert that one to 0, and the rest of the things will be placed as it is. So I hope you have understood how this negation works. I have explained with positive and negative values also. If you find anything difficulty, I suggest you to go through the video again so that you could able to understand. So let's go ahead and understand one more thing, which is of shift operators. In shift operators, we have two different shift operators. One is left shift, another one is right shift. Let us understand left shift first. So left shift can be represented with something like this. So let us understand how this left shift works. So to understand, I am passing, let's say 5. I wanted to shift, uh, let us take some big number. Let's say 84. I want to shift two values. I want to shift that binary digits of three values. So what will be the output? So I am getting 672. How I am getting 672? Let us understand. So I am converting this 84. Whenever I am converting this 84, I am getting this binary representation, and left shift works in a such a way that this binary represent this value is there, right? So let us copy these values. This is what we are trying to convert, and this value is multiplied with 2, and it will rise to the power how many bits that we are mentioning here, how many shifts that we are mentioning here. Here I am mentioning 3 shifts. So the power can be calculated by using this exponential operator. So that is what I am mentioning here, and I am mentioning 3 here because three shifts, that is what we wanted to convert. So that is the reason I am mentioning 3 here. So if I execute this, I am getting the same result as we have getting by mentioning this shift operator. So by this, you can able to understand how we are getting the shift operators. Shift. Let's go ahead and see with binary example. I have this binary value, right? So I have this value, and how does this works is that it will try to shift 3 bits to the left side. Let me consider this also. So before doing that, we will take this itself, right? So that could be a good way. So I am passing this binary, and I am passing this whole thing, whole operation, what we are doing here. So here, by mentioning this in binary operations, I am getting this value. So let me copy this so that we can compare it easily. So that this is the original value that what we are passing. This is the original value of this is the original value, and this is what the resultant value that we have got, right? So to understand it clearly, we have mentioned 3 shifts, right? So you can initially observe we have got 3 additional values in the resulting value. So how does this works is that initially the values will be something like this. 3 zeros will be present initially. So after mentioning these shift operators, these 3 values 101 can be shifted 3 digits, and all these value shifted 3 times to the left side. So by shifting 3 times to the left side, we are getting this result. So you can able to see 1 is moved to here, 0 is moved to here, and 1 is moved to here. Like this, all these values is shifted 3 steps to the left side. So because of that reason, we are getting this result. So if we mention this in binary representation, we will get the same result. In integer representation, we will get the same result. I am mentioning here 2. Now I can able to get this result. So I hope you have understood how this shift works. It will initially having zeros initially, initial whatever the beginning they are. So by mentioning that shifts those many steps that the binary value should be moved to the left side. So to calculate, we can actually use this way also by mentioning multiplied with 2 and raised to the power how many shifts that we are mentioning. So that is about left shift. Let's go and understand this right shift also. So right shift is represented with something like this. So we have seen the left shift, right? So let us take the same example here. So instead of left shift, I will be mentioning as right shift. So I am getting just 10. So how I am getting? So this will be represented with initially. Previously we have seen this will be multiplied with 2, but whereas in here this will be left shift will be multiplied and right shift will be divided. So I am having this value 84. This will be divided. So it will be divided by removing those decimal values also. Because of that reason I am mentioning this. So it will be divided with 2 raised to the power how many shifts that we are mentioning. We are mentioning 3 shifts. Because of that reason, we are getting the same result as we are getting from this shift operator. I hope you have understood what is the difference between left shift and right shift. In left shift, we will multiply. In right shift, we will divide. So this is how this works. Let us represent with binary way. I have this 84 in binary representation. I am getting this. Now I will be representing these binary digits by mentioning this value. So if I mention this, I am getting only few binary values. If you carefully observe here we are having 7 binary values. Here we are only getting 3. Let us compare this. Let us try to compare this. I am giving plain 84, and I am giving by doing shift operator. I will remove this, and I also remove here also. If you consider here, if you carefully consider here, in 84 we are having these many binary values. In by shift operator we are getting only 4 values. Here these 3 values will be removed. That is how the right shift works. So I hope you have understood. There is no need of much explanation here. These values at the end will be removed and these will be shifted three steps to the right side. That is how right shift works. I hope you have understood what exactly right shift, left shift, and to summarize what we have discussed in this video, we have seen binary operators, and initially we have seen how to convert binary values to integer value and integer value to binary value. Going ahead, we have understood how we can do bitwise AND operator and bitwise OR operator and bitwise XOR operator. We have also seen bitwise NOT operator, and going further, we have seen shift operators. Specifically, we have two shift operator, left shift and right shift, and we have seen everything. I hope you have understood the whole video. If you are not, I suggest you to go through the video once again so that you could able to understand it clearly. If you find this video interesting, hit the like button and subscribe for more. Hit the notification bell icon so that whenever I post a new video, you will get the notification. And that's it for this video. See you in the next one. Thank you.